it got a lot of coverage from start to finish. All the titles you see here are many more covered from the initial announcement they found results right through to the problems that they announced. The way the media reacted was very different. Tabloids tended to go for examples like this, focusing on the idea that Einstein could be wrong, and mentioning science fiction ideas like time travel and possibilities. Other places like New Scientist, Nature, BBC were much more objective, and they preferred to focus on the idea that the early result was likely to be wrong, and was probably destined to slight error. The popular quote here from Professor Jim Appellini from the University of Surrey, saying that he really wasn't sure that the result proved to be right. That got a lot of coverage, so obviously not everyone was convinced by it, and it looks like it's probably late now. The story also made it into a top 10 for top 10 science and physics stories for a few different types, such as News Right and The Guardian. So it's very widely covered in the media. We also looked quickly at the social media response to it. It got almost 50,000 tweets, and that was before they announced the problems. That number should be a bit higher now. But it didn't make it into 2011 top topics on Twitter, and it wasn't one of the too much shared stories on Facebook, so it only got mediocre social network response, really. The very last thing we did the Oxford and release their results too early. They originally announced their findings towards the end of September, but they didn't submit it for peer review until the end of November. And there were 15 team members initially who weren't happy to have their name on the paper properly, and even when they submitted it for peer review, there were still 6 or 7 team members that didn't want their names on the paper. But the justification by the team here, this last quote demonstrates that, is that they themselves, as Anton mentioned, looked for months to find any errors they could with there and try and explain it, and they couldn't. They wanted to send it out to the scientific community to let them scrutinise it and tear it apart, see if they could find any problems. And when they didn't, that's when they submitted it for peer review. That's all we've got, so I'm going to hand you back to Callum now, who can give you a conclusion.
So, given all the work that we've done into this project, examining the experiment itself, similar experiment, we have come to a final conclusion. With the disagreement with special relativity being such a huge topic, it's a really well-established theory. Breaking it was such big news, and with Opera now having these significant systematic errors, it's really cast a shadow of doubt on their results. What with the previous experiments such that Callum mentioned not agreeing with Opera's result, this also cast further doubt. And now that Icarus has released its statement that they've discovered that neutrinos do not travel significantly different speeds than that of light, it's really put the nail in the coffin to the question. So, are neutrinos faster than light? With an extremely politically correct conclusion, we say that there is no evidence available at this time to statistically suggest it's So, at this time, we'd like to say a big thank you to Frank Smith, who ordered all our members, ordered all of our meetings, and to Dr. David Waters, who gave us a lot of help with the content. And I'd like to open the floor for any questions.
Yeah, I think what you're referring to there, I think the neutrinos were detected before the photons arrived, and our understanding of whether the neutrinos were faster than light or that relies on our current model of scientific which states that the photons, I think you will know better when they release. Are they released before the
neutrinos are released about a few seconds after the first burst, and the photons about an hour later than the outer shell was lit and allowed the photons to leave. but this given about an error 3 hours for our estimation of the arrival of the photons and the neutrinos, and this value of the velocity of neutrinos was an approximation, but still is our best result that we have today.
If the upper result is right, it's likely the neutrinos have been expected to give the same earlier than the photons arrive at Earth. If the upper result is completely neutrinos.
There is just some more information. There is a kind of in theory part. There's a theory to explain that is because the speed of the neutrino is also energy dependent, which is called a four-neutron string, and that's explaining the apocalypse.
Okay, now if you answer that question, because I think that was your question really. Can you reconcile it?
Yeah. There's a
Yeah.
Before you ask the question to your problem, let's see if everybody else
Sure.
wants to I've got a question for all of you. Would you put your name on that paper?
I would personally, because having read that paper probably several times, it is incredibly rigorous. Their analysis, they've accounted for absolutely everything. They've got a list of, as long as you are, the things they've calculated and they've negative. The nature of the two results, I mean, they basically got the delay on one of the cables wrong, and they got their timing using the GPS slightly wrong. That does not come through in the paper at all. You don't read the paper to account. That's unfortunate. So, yeah, personally, I would.
Neutrinos are traveling through the Earth, going from CERN to operate. Does this change the superconduction of the neutrinos? For example, could the velocity be modified through that via that?
If it is, it would be modified so it looks like it would slow down. So that would, the fact that the neutrinos can detect it, we can't go back into it despite that. So that would even reaffirm the conclusion that they are superior.
We also analyzed the paper saying that due to the uneven distribution of mass inside Earth, actually the matrix could start change and allowing the neutrinos to travel a bit faster than the superstars.
Can I actually pick up on Sam's question again, because maybe you will change your mind now. So you would like to actually go ahead with it, but one thing is to put the paper in the archive. The other is to call what would effectively a press conference at SORT to announce why the result. We can do that with this kind of evidence in your hand.
Yeah, if they want to get out there to the scientific community.
But you can do it by just publishing it on the archive.
Yeah, but essentially it's got the same coverage that they did there. So I think, yeah, it's such an hard thing as well. And if it was right, they just wanted to make it clear that
So you will still do it. You will still do it.
I think probably, yeah, right.
How much money did this experiment cost, and rerunning it as well? And where's the money coming from?
Don't know the actual value, but this was the only secondary thing it investigated. Primarily, it is looking into the neutrino